The mathematical forms of Freundlich adsorption isotherm are rate of adsorption x by m is equal to k into p to the power 1 by n. This is one form. Here 1 by n takes the value 0 to 1, that is less than 1, greater than 0. Or you can say n is greater than 1. Another mathematical form of Freundlich adsorption isotherm is logarithmic form, that is log x by m is equal to log k plus 1 by n log p. In fact, these two expressions are in the form of equation for straight line. So, the plot of x by m versus p to the power 1 by n will be a straight line passing through the origin. Plot of rate of adsorption against pressure is a straight line passing through the origin, and slope of the straight line is simply equal to k, that is adsorption coefficient. In fact, this plot shows slight deviation after certain pressure, at higher pressure. This implies this isotherm holds good only at low pressure. At high pressure, there will be deviation. The pressure corresponding to this deviation is known as equilibrium pressure, adsorption equilibrium pressure. Okay. Now let us see the plot of this expression, that is plot of log x by m against log p. It is also in the form of straight line. Here the plot of log x by m against log p will be a straight line, but not passing through the origin, and it has a positive slope like this. Slope of the straight line is equal to 1 by n, from which we can get the value of n. This plot on extrapolation makes an intercept on rate axis, and this intercept is equal to log k. Intercept is equal to log k. So, by using the intercept value, you can get the value of k. K is equal to antilog of intercept. See, these two plots are known as adsorption isotherms. Okay. Now, we shall see the plots of adsorption of a gas on a solid at different temperatures. Adsorption of gas on solid at different temperatures. That is here. See, at different temperatures, the adsorption isotherms for a given adsorption process are like this. Say at T1 temperature, at T2 temperature, this at T3 temperature. See, T1 is less than T2, less than T3, so on and so forth. See, these plots are adsorption isotherms for a gas on solid shows on rising the temperature, the rate of adsorption decreases. This clearly gives the effect of temperature on adsorption. For adsorption, low temperature is favorable. Of course, at an optimum temperature, rate of adsorption is very high. Beyond that temperature or above that temperature, the adsorption decreases. That means rising the temperature leads to desorption. Rising the temperature leads to desorption. So, rising the temperature, rate of adsorption decreases. Now, let us consider the adsorption plots or plots of rate of adsorption against temperature. Rate of adsorption against temperature. Plots of rate of adsorption versus temperature are known as adsorption isobars. Previous cases, adsorption isotherms. Plots of rate of adsorption versus pressure, known as adsorption isotherms. Plots of rate of adsorption against temperature, or you can say that rate of change of adsorption, rate of adsorption with temperature, known as adsorption isobar. Rate of change of adsorption against pressure, known as adsorption isotherm. So, you know, there are two types of adsorption processes. One is physical adsorption, another one chemical adsorption. Now, let us see the feature or shape of adsorption isobar for physical adsorption and chemical adsorption. Physical adsorption, see, for physical adsorption, the isobar is like this. For physical adsorption, the adsorption isobar is like this. It shows at low temperature, rate of adsorption is very high. On rising the temperature, rate of adsorption decreases and becomes steady. Okay. What about it in case of physical adsorption? See, this is in case of physical adsorption. In case of chemical adsorption, it is. See, on rising the temperature, the chemical adsorption increases. So, higher temperature is favorable for chemisorption, whereas low temperature is favorable for physical adsorption. But too high temperature not favorable for any kind of adsorption. In case of physical adsorption, low temperature favorable. On rising the temperature, rate of adsorption decreases. Whereas in the case of chemical adsorption, rising temperature increases the rate of adsorption. It is true up to certain temperature. Okay. See, the plot is like this. This is in the case of chemisorption. Okay. It shows on rising the temperature, rate of adsorption increases up to certain temperature. Of course, the temperature is known as optimum temperature. Beyond the temperature, rate decreases. That means desorption takes place. That is, adsorbed molecules or particles will be detached from the surface of adsorbent. That means desorption takes place. This is due to the fact, of course, on rising the temperature, the thermal agitation between the adsorbed particles develop. As a result, they detached from the surface of adsorbent. So, these two plots are known as adsorption isobars. So one for one for chemical adsorption, another for physical adsorption. This about Freundlich adsorption isotherm. There is another type of adsorption isotherm generally considered, that is known as Langmuir adsorption isotherm. Langmuir's adsorption isotherm. This Freundlich adsorption isotherm holds good only at low pressure, whereas this Langmuir adsorption isotherm holds good at all pressures, low or high pressures. Here I will give the mathematical form of Langmuir adsorption isotherm for the sake of your entrance examination. The mathematical form of Langmuir adsorption isotherm is rate of adsorption, that is x by m. You know what are x and m. Here x is amount of adsorbate, m amount of adsorbent or mass of adsorbent. This is equal to AP by 1 plus BP. AP plus 1 by BP. Here P stands for pressure, A and B are constants. A and B are constants. In some books, A and B are written as K1, K2 like that. Okay. This adsorption isotherm holds good all pressures. Next, shall pass on to another bit of this adsorption chapter, that is factors which influence, which affect on the adsorption of gas on solid. Adsorption of gas on solid. See here, solid is adsorbent, gas adsorbate, for which you can give an example. Adsorption of chlorine gas on activated charcoal. Okay. See, in the examination you may be asked, mention any two factors which influence on the rate of adsorption of gas on solid. See, there are some factors which influence on rate of adsorption. First one is nature of adsorbate. Nature of adsorbate. Second factor, nature of adsorbent. Next one, temperature. Fourth, pressure. These are some important factors which influence on the rate of adsorption of gas on solid. First, nature of adsorbate. The adsorption process depends upon nature of adsorbate. If adsorbate, that is gas, is more easily liquefiable, then its adsorption is very high. More easily liquefiable gases can more easily adsorb on solid adsorbents. See, more easily liquefiable gases have higher critical temperature. If a gas has higher critical temperature, it can be more easily liquefied and it can more easily absorbed. Let me examine here. Say there are gases A, B, C and D. Their critical temperatures are A 27 Kelvin, B 105 Kelvin, C 10 Kelvin, D 200 Kelvin, like that. Which gas can be adsorbed more easily on a solid adsorbent, or give the increasing order of rate of adsorption of these gases ಅಂತ ಕೇಳ್ಬೋದು. ಏನಿದೆ ಇದು ಕಂಡೀಷನ್? higher the critical temperature, more easily liquefiable. Gases which have higher critical temperature can be more easily liquefied, and such gases can more easily adsorbed. Here the gas D has higher critical temperature, next B, next A, C. So D, the gas D can more easily adsorbed on the solid adsorbent than the gas B, which in turn more easily than gas A. So order, increasing order of adsorption is C least adsorbed, then A, then B, then D, or this is most easily adsorbed, least easily adsorbed. So this is one important factor. Next one, nature of adsorbent. What is adsorbent? It is the substance which provides surface for adsorption. Greater the surface area of adsorbent, greater will be the number of active centers, active spots present, then or consequently greater will be the rate of adsorption. If adsorbent provides larger surface area, there will be larger number of active centers, consequently more number of adsorbate particles can adsorb. This is the reason. Of course, you can increase the surface area of a solid adsorbent by breaking it into number of pieces. If you break a solid, the surface area increases. When surface area increases, number of active centers also increased. When number of active centers become more amount of adsorbent can adsorb. This is the reason why solid adsorbents are always used in the fine powdered state. Example ಕೇಳ್ತಾರೆ. Give reason. Solid adsorbents are always used in a fine powdered state. Or why ಅಂತ ಕೇಳ್ಬೋದು. Reason is simple. In the fine powdered state, surface area is more, and there the number of active centers present will be more. As the consequence, more amount of adsorbate adsorb or can adsorb. That is. Next bit is temperature. As you know, low temperature is favorable for physical adsorption, whereas high temperature is favorable for chemical adsorption, but too high temperature is not favorable for any type of adsorption. At very, very high temperature, that is beyond optimum temperature, desorption favors. That means the adsorbed molecules may be detached from the surface. Next, pressure. On rising the pressure, rate of adsorption increases, because on applying the force on adsorbate, more amount of adsorbate firmly fix on the adsorbent. So, increase of pressure increases the rate of adsorption. But too high pressure, once again, too high pressure may lead to desorption. Too high pressure may lead to the desorption, for which I will give one simple example. ನೀವು ಹೋಗ್ತೀರಾ ಪ್ರಿನ್ಸಿಪಾಲ್ ಹತ್ರ, ಪ್ರಿನ್ಸಿಪಾಲ್ ಕೂತ್ಕೊಂತಾರೆ ಅವ್ರ ಮುಂದೆ ಇರೋ ಚೇರಲ್ಲಿ, ನೀವು ಕೂರಲ್ಲ, ಕೂತ್ಕೋಪ ಅಂತ ಹೇಳಿ ಒಂಚೂರು ಫೋರ್ಸ್ ಮಾಡ್ತಾರೆ, ಅವಾಗ ಕೂತ್ಕೊಳ್ಬಹುದು. ನೀವು ಹಾಗೂ ಕೂರದೇ ಇದ್ದರೆ ತುಂಬ ಪ್ರೆಷರ್ ಹಾಕ್ಬೋದು, ಕೂತ್ಕೋತೀವೋ ಇಲ್ವೋ 4 ಬಾರಿಸ್ತೀನಿ ಅಂತಂದರೆ ಇವ್ರ ಸವಾಸ ಬೇಡ ಅಂತ ಓಡೇ ಹೊರಟೋಗ್ತೀರಾ. ದಟ್ ಮೀನ್ಸ್ ಅಟ್ ಹೈಯರ್ ಪ್ರೆಷರ್ desorption develops. So, these are the 4 important properties or factors which influence on the rate of adsorption. Another factor is there, that is by reactivating the active centers of adsorbent, solid adsorbent. But these 4 are important one. So, this is about adsorption. Next we shall see applications of adsorption. Adsorption technique is used in different fields. Just see, adsorption technique is used in making gas mask, particularly the gas mask used by the miners, that is the persons who work in deep mines. In the mines, some poisonous gases exist, particularly chlorine, cyanogen gas, that is hydrogen cyanide, carbon monoxide, etc. Actually, those workers used to wear gas mask which contains suitable adsorbents, which adsorb only those poisonous gases. So, adsorption technique is used in making gas masks. One. Second one, it finds application in metallurgical field, that is in the extraction of metal, particularly in the concentration of ores by froth flotation process. Adsorption technique is used to concentrate low grade sulfide ores by froth flotation process, where pine oil is used as an adsorbent, of course to remove siliceous matters, etc., or GANS particles. So, in metallurgy you can find its application. Next, it finds application in the volumetric analysis also, that is in using adsorption indicators. Adsorption indicators. The commonly used adsorption indicators are fluorescein, magnesia mixture, etc. Next, that is in volumetric analysis. Next, it is used in the separation of noble gases, that is in the separation of noble gases, helium, neon, argon, krypton, xenon, etc. Coconut charcoal is used as adsorbent. Then it finds application in the purification of water also, that is by ion exchange method, in of course by using deionizer. Next, it finds application in chromatographic technique of separation of some substances, colored pigments, etc., etc. It finds application even in medical field. Say, the ointments applied on wounds act as adsorbent, on which the germs get adsorbed. These are few applications of adsorption. That's all about the adsorption chapter. Okay.